Okay, so last video we made about half of our guessing game so far and also introduced the idea of ownership. Today we're going to be finishing up the guessing game. Before we begin, we're going to put this part of the game in a loop since we're going to be guessing until we get the right number. So, like we went over earlier, a while true loop is just simply loop, and I'll go ahead and move this into the loop. At this point, we have a random secret number and the user's guess down here. Now we need to convert the user's input into a number and compare it against the secret number. To parse the user's guess, we're going to begin looking at some Rust documentation to get used to that. Now, the naive Rustacean is going to start Googling or asking their favorite LLM about what string method we should use to parse the string, our guess, into a number. The Chad Rustacean, on the other hand, is going to utilize the built-in doc commands to access the ready-to-read and offline documentation. To access these documents related to the standard library, since string is part of the standard library, we're going to use a command called rustup, which is our toolchain manager, doc. I'm going to do that, and that just popped open a browser window for me. And would you look at that? And again, we haven't used rustup before, but we can use it to also install and switch to different versions of Rust. But we're using it also to view documentation for the current version of Rust. And as you can see, it gives us quite an extensive collection of resources. In this case, we're just trying to figure out what method we should call in string, so I'll scroll down here to our API documentation for the standard library. Note that all these docs are already saved on your machine, as you can see, so you can save yourself the extra bandwidth or show off your savvy Rust skills to those next to you if you're on a plane or something like that. We can also use rustup doc -- standard as a quick way to get to the standard documentation. Boom. So now that we're here, let's go to the prelude real quick. This is all the stuff that's baked into the prelude, as we just said. Let's keep scrolling down. And oh, would you look at that? The string module that we've been using is in the prelude, in the string type. String. That makes sense, right? So let's navigate to our string type. As you can see, we have access to pretty much everything under the sun concerning the string type, along with some examples up top if I scroll back up real quick. A couple of examples of how to use the string type. Let's start, well, we're trying to parse a number, right? So let's start by searching the page for number. It's not giving us exactly what we want, right? What about parse? Let's try parse. Oh, would you look at that? A parse method exists. Let's click on it. Parses a string slice into another type. That's exactly what we want. And it even has an example of how to use it down here. So let's go ahead and shadow our guess. And we want to parse it into an 8-bit integer. .parse. But it also makes sense to trim the new line before parsing because guess line, as we can see here, the trailing new line character is included in the buffer. So we don't want to parse the new line character, so we'll do a trim. And again, you can find this on the documentation as well. And also, as we saw from the parse documentation, if we go back to it real quick, is that it returns a result type, which we should be a little bit familiar with at this point. This time, let's use a match expression to unwrap the value of the parsed integer. And let's match if it's okay, value, and we just want to get the value. If it's an error, and we don't care what's in the error, then we're gonna print out a nasty message. And whoops, let me correct that real quick. I'll be nice. Please enter a number. And then we're going to continue. And again, that's the cool thing about Rust, is that we're able to do logic within our expression before guess even gets assigned a value. So here, before guess gets assigned anything, we're just exiting early and going back up to the start of the loop. And you can see how this can help us from writing a bunch of nested if statements, right? And I'll add that before we continue, we can look at the documentation relevant to our project using cargo doc open. This will generate documentation for everything in our project minus the preload and standard library, since that's more related to the toolkit we're using and not the external crates we're using. That makes sense, right? We can go through our documentation and go into Rand, and we can look at the thread RNG function to see if we get a thread RNG instance. Feel free to poke around in here and see if you can understand how thread RNG ties into the RNG trait that we imported up here. We haven't gone over traits yet, but might be a fun exercise. Okay, we finally have our two numbers, guess, which we just shadowed, and then our super secret number up here. And we should probably cast this to, well, we want these to be the same type, right? So we have two options. We can either cast this or just parse it to 32-bit unsigned. Let's go ahead, and it'd be less work to just parse this into a 32-bit unsigned. Now we can do something like if guess is less than super secret, else if greater than, else. But this is starting to match a pattern that we should be starting to get familiar with. Pardon the pun. We are attempting to cover all possible branches of a conditional. So instead of doing this else, if else, trying to catch everything, we'll let the compiler check that we're catching all the possible branches by using the CMP or compare method on guess. So guess dot CMP compare against super secret number. As you can see, this returns an ordering type. So let's go ahead and import that using use standard CMP ordering. And then let's match with the possible variants. And that could be either ordering equal, ordering less, or ordering, hi Arnold. Arnold's my cat. Stop biting me, dude. Or ordering greater. And then let's print messages for each of these. So if it's equal, print out that you have won the game. And let's break from our loop. If it's less than, hi Arnold, your guess is less than the secret And then we don't need curly brackets for a one-liner. Guess is greater than the secret number. And again, I'll just clean that up a little bit. And then, of course, we need commas after all these. Oh, and look at that. The compiler is being nice to me. It wanted a reference to this 32-bit, not the 32-bit number itself, so I'll go ahead and pass a reference to it. And again, we can have as many read-only references as we want. What else is it saying? Oh, of course, I did a silly mistake there. And that's it. We briefly covered on how to use Rust built-in documentation to look up the parse method, compared our guess with the super secret number, and handled parsing errors. Oh, yeah, lowercase. And handled parsing errors with match as well up here. And let's go through the game one time and make sure it works. So the super secret number, of course, this isn't part of the game in our finished game. We're gonna, that's debug, and we can take that out of our final game, but it's good to know that the secret number is 42, so let's guess 5. Our guess is less than the secret number. Let's try 50. My guess is greater than the secret number. Let's try Arnold. Oh, that's not a number. Let's try 41, 43, 42. We won. Yeah, we did it, Arnold. Give yourself a pat on the back. We're making some serious headway and are about to be done with the language fundamentals. Next up, we're going to look at arrays, vectors, and hash maps. See you in the next one.